Hello dear students, this is Mr. Hitesh Patel, Assistant Professor LJ Institute of Engineering and Technology. In this video series, we will discuss a subject Basic Mechanical Engineering. Today in this video session, we are going to discuss a topic that is air compressor. Okay. So first of all, in our daily routine life, we have already used this device for filling the air inside the tire of vehicles. Okay. So what is the function of air compressor? So the machine which takes air or any other gases at low pressure and compresses it to high pressure, or this device is known as air compressor. Okay. So air compressor sucks the air at low pressure and supplies the air or any other gases or vapor at high pressure. So on which basis compressors are classified? So first of all, the compressor is classified on the basis of method of compression. In method of compression, the compressor is classified into three categories: reciprocating compressor, rotary compressor and centrifugal compressor. So in reciprocating compressor, the compressor compresses the air or any other gases or vapor by reciprocating motion of the piston. Okay. In rotary air compressor, the air is compressed by rotodynamic or rotary motion of the impeller. And in centrifugal compressor, the air is compressed with the combined effect of rotodynamic as well as centrifugal force. By this way, the air is compressed. Okay. The second classification of the compressor is according to delivery pressure. So low pressure, medium pressure and high pressure, and fourth one is very high pressure. So low pressure, so the pressure up to 1.1 bar, that are the classified as low pressure compressor. The pressure up to 1.1 to 8 bar, that are medium pressure compressors. 8 bar to 10 bar, that are high pressure compressor, and very high pressure compressor are above 10 bar. Okay. Next classification of compressor is according to the principle of operation. According to principle of operation, the air compressor are classified mainly into two types. First is positive displacement compressor and second is rotodynamic or steady flow compressor. In positive displacement, the displacement of the piston takes place, and due to that positive movement of the mechanical element, there is a negative pressure is generated. Due to that, suction of air or gas or vapor takes place. After that, the air or gas or vapor is compressed and the air compression takes place inside the compressor. In rotodynamic, due to dynamic action of the rotating element which is known as impeller, the air is compressed and there is increase in pressure takes place. Okay. So this is the basic of the principle of operation of the air compressor. Next is volume of air delivered. According to volume of air delivered, the air compressors are classified low capacity compressor, medium capacity and high capacity compressors. In low capacity compressor, the volume flow rate is up to 10 meter cube per minute. In medium capacity, the volume flow rate is up to 10 meter cube per minute to 300 meter cube per minute, and in high capacity, the volume flow rate is above 300 meter cube per minute. The air compressors are classified according to the number of cylinders. So it is classified according to single cylinder and multi-cylinder. In single cylinder, there is only one cylinder is there. In multi-cylinder, two or more cylinders are installed inside the compressor for compress the air, gas or vapor. The pressure limit. So fans, blowers and compressor. The pressure ratio for fans is up to 1 to 1.1. For blowers, the pressure ratio is 1.1 to 2.5, and for compressor, the pressure ratio is about 2.5. Number of stages, that is single stage compressor and multi-stage compressor. In single stage compressor, the compression of the air takes place only in single stage. In multi-stage compressor, there are multiple stages are there, and for that we need intercooler between the each and every stages, and in multi stages we can achieve higher pressure. So in single stage compressor the pressure is up to 5 bar. In multi-stage compressor the pressure is above 5 bar. Okay. Fluid to be compressed. The compressor is classified according to the which fluid we are compressing. If we are compressing air, then that device is known as air compressor. If we are compressing gas, then that device is known as gas compressor. If we compress the vapor, then it is known as vapor compressor that we are using in refrigerators. Okay. So this is all about the classification of the air compressors. Okay. Now, which are the applications of compressed air or which are the uses of compressed air? So, in refrigeration cycle for compressing the refrigerant, compressor is used. In operating pneumatic tools, for the pneumatic tools for generating pressure of air, there is a compressed air is used. Filling the air in automobile tires, that is also one application. Spray painting, increase in inlet pressure of IC engine, pumping of water, gas turbine power plants, for sand blasting, for operating blast furnaces, operating air brakes used in buses, trucks and trains, conveying material like sand, concrete along a pipeline. All these are the application of compressed air, and for compressing air we required air compressor. Okay. So next is reciprocating compressor. Okay. So in reciprocating compressor, how this compressor works or general or basic operation of air compressor. So in air compressor, first of all, in first figure, you can see that there are two valves is provided at the top of the cylinder head, that is suction valve and second is discharge valve. Inside that cylinder, a piston is fitted and piston is connected with the connecting rod and crankshaft. So during starting, when the piston is travel from TDC to BDC, there is negative pressure is generated inside the cylinder. Due to that negative pressure, the volume inside the cylinder is increased, pressure inside the cylinder is decreased, and at that time that suction valve will remains open due to the pressure difference, and due to that pressure difference the atmospheric air suck inside the cylinder. Okay. After that piston travel from BDC to TDC. During this stroke, due to the pressure, both the suction valve and discharge valve will remain closed, and at that time piston travels from BDC to TDC and the air compression takes place between the cylinder head and piston head. After achieving maintaining some amount of pressure of air, after that the discharge valve will remains open and we can discharge that air to the cylinder or vessel where we need to store that compressed air. Okay, so this is the basic operation of reciprocating air compression. Okay. Now we will discuss the work for compression without clearance. The operation of the compressor is carried out by two ways. First is work of compression with clearance and work of compression without clearance. Means there is no clearance volume is provided in this operation, in without clearance operation. Okay. So during starting, when the piston travels from TDC to BDC, at that time a negative pressure is generated inside the cylinder, and due to that negative pressure the suction valve will remains open, delivery valve will remains closed, and at that time there is suction of air takes place from the atmosphere to the cylinder until there is constant pressure is maintained between the outside atmospheric pressure and inside the cylinder. So this process is represented by line 4 to 1 on PV diagram. After that the piston will travel from BDC to TDC. When the piston travel from BDC to TDC, at that time the air is compressed between the cylinder head and piston head, and there is compression of the air takes place, and we know that when the air is compressed, at that time there is a increase in pressure and decrease in volume takes place, which is represented by line 1 to 2 on PV diagram. Okay. After that, when the pressure inside the cylinder becomes equal or more than the receiver's pressure, at that time that spring loaded outlet valve will remain open, and during that stroke or during this operation, the air which is compressed will enter inside the receiver where we need to store it. This process takes place until constant temperature is maintained. This line is represented by 2 to 3 on PV diagram. Okay. And after that, again the cycle is repeated from 4 to 1, 1 to 2 and 2 to 3. This is the work of for compression without clearance. So, if the compression takes place adiabatically, then in this case we are taking total 3 cases, whether the compression is adiabatic, whether the compression is polytropic, or the compression is isothermal. Okay, so if the compression is adiabatic, then first of all we need to calculate the area covered below the PV diagram, that is the area of 1, 2, 3 and 4. First of all, area under the curve 2 to 3, that is 2 to 3, so that will be square. After that, area under 1 to 2, that is indicate the adiabatic compression process. After then we will minus the curve from 4 to 1, that is 4 to 1, that square rectangular shape will be minus from that. If we put each and every equation for this, then we will get the adiabatic work done per the cycle. Okay, so area under the curve 2 to 3, that is square. Okay, so area, that is its length and breadth, so its length is P2 and breadth is V2, so it is the multiplication of P2 V2. After then the area under the curve 1 to 2, that is adiabatic compression process, and we know the equation for adiabatic compression, that is P1 V1 minus P2 V2 divided by gamma minus 1. But at that time there is expansion takes place, but here in this case the compression of the air takes place, so the term will be reverse, so the equation will be P2 V2 minus P1 V1 divided by gamma minus 1 and minus area under the curve 4 to 1, that is P1 V1. So after taking common the term P2 V2 minus P1 V1, we will get gamma divided by gamma minus 1 in bracket P2 V2 minus P1 V1. If we take P1 V1 as common from this equation, we will get gamma divided by gamma minus 1 P1 V1 in bracket P2 V2 divided by P1 V1 minus 1. Okay. But we know that during adiabatic compression process, P1 V1 raised to gamma is equal to P2 V2 raised to gamma. So we can rewrite this equation as V2 by V1 is equal to P2 by P1 raised to 1 by gamma, and we are putting this value V2 by V1 in equation number 1. So by putting the value in equation number 1, we get W is equal to gamma divided by gamma minus 1 P1 V1 in bracket P2 by P1 raised to gamma minus 1 divided by gamma minus 1. So this is the work done during adiabatic process in case of compression without clearance. If there is a polytropic compression, we all know that in adiabatic process there is gamma. If we replace that gamma by adiabatic in polytropic index n, we get all the equation for the polytropic process. So the equation for the polytropic process will be W is equal to n divided by n minus 1 P1 V1 in bracket P2 V2 divided by P1 V1 minus 1. So the final equation will be n divided by n minus 1 P1 V1 in bracket P2 by P1 raised to n minus 1 upon n minus 1. This is the equation for polytropic compression. Okay. Now if there is isothermal compression takes place between 1 to 2, then we will take W is equal to P2 V2 plus the work done during process 1 to 2, that is P1 V1 log V1 by V2 base E, because here in this case the compression of the air takes place. If there is expansion takes place, then we will reverse that volume ratio, that V2 by V1, but here in this case there is compression of the air takes place. So we will take P1 V1 log V1 by V2 base E minus area under the curve 4 to 1, that is P1 V1. So this is isothermal process. That means P1 V1 is equal to P2 V2. So by putting the value P1 V1 is equal to P2 V2, we will get W is equal to P1 V1 log V1 by V2 base E, because P2 V2 is equal to P1 V1. So P2 V2 and P1 V1 both term gets cancelled, and the final equation will be P1 V1 log R base E. So W is equal to PV log R base E. So this is the work done during compression in case of non-clearance volume. Okay, in case of isothermal process. So if you have any queries in this video session, then you can write down your comment in the comment section. Thank you for watching my video.